Since December 2021, the James Webb Space Telescope has unveiled numerous secrets of our universe. It has provided new images of galaxies, complementing those from the Hubble Space Telescope, and has expanded our understanding of supernova remnants, peering into the early universe. This spacecraft has already made significant discoveries. In its latest observation, the powerful Webb telescope has captured a new deep field view of the universe, offering a glimpse into some of the farthest reaches of space. In this image, hundreds of objects are visible amidst the black ether of the cosmos. These are galaxies, each teeming with stars and planets. Many resemble spirals akin to our Milky Way galaxy. The deepest galaxies appear red, as their light has been stretched into longer wavelengths due to the expanding universe. But that's not all. This view looks back billions of years, revealing ancient galaxies and black holes at their centers, merging just a couple of 100 million years after the Big Bang. Join us as we delve into this new Webb telescope photo that truly boggles the mind. At the beginning of everything, the cosmos underwent a period of rapid expansion. Space expanded exponentially, stripping reality of form and creating a near-featureless void. If you could have sat on an atom, though atoms did not yet exist, and gazed out, you would have seen nothing but freezing, suffocating darkness. As space expanded relentlessly, all other objects were carried far out of sight faster than the speed of light. Paradoxically, while space expanded, the observable world shrank to a tiny, inescapable nutshell, isolating every speck within its own sphere of nothingness. This era of extreme expansion is known as inflation. Its duration remains a mystery. Whether it lasted an instant or an eternity, we may never know. Any traces of earlier epochs have been erased by this cosmic growth. However, at some point, inflation ceased, and the universe burst into existence. The force behind inflation dwindled, birthing countless particles that filled the expanding void with a blazing, subatomic fire, the primordial plasma from which all cosmic objects would later form. Within a trillionth of a second, the fundamental forces of nature emerged, marking the first and greatest blaze of light in cosmic history. Although inflation ended, space continued to expand at a slower pace. As the cosmos grew, the primordial fire cooled, and elementary particles fused to form the first atoms. Over the next few minutes, the nuclei of hydrogen, helium, and lithium were forged, the building blocks of everything yet to come. For approximately 380,000 years, the infant universe glowed with incandescent fire, gradually cooling as space expanded further. Then, a critical moment arrived when the temperature dropped enough for electrons to bind with atomic nuclei, forming the first complete atoms. At this juncture, the primordial flame extinguished, plunging the cosmos into darkness. Thus began a long dark age. Over hundreds of millions of years, the universe was shrouded in a warm hydrogen fog. Yet within this darkness, the first structures began to form, initially slowly, then accelerating. Hydrogen and helium coalesced under gravity into denser clouds, which heated up as they grew more compact. Eventually, in one such cloud's core, pressure reached a critical point, igniting a nuclear fire, the spark of the first starlight. From this newborn star, light flooded back into the universe, signaling the end of a dark age and the beginning of a cosmic dawn. Soon, the universe was dotted with stars, gathering into the first galaxies. These stars synthesized elements like carbon, oxygen, nitrogen, and iron, which were dispersed throughout space. As these first stars died in supernovas, they seeded space with even more elements, perpetuating a cycle of birth, death, and rebirth. Around 9 billion years after the cosmic dawn, in an outer spiral arm of one of the billions of galaxies now dispersed through space, a new star flickered into existence. About it circled a fleet of worlds, and on one rocky sphere, Earth, matter somehow came to life under the guidance of fundamental physical forces. Atoms arranged themselves into increasingly complex organisms that grew, multiplied, and evolved over billions of years. The pale blue orb teemed with life. Species emerged, thrived, and perished in the ongoing dance of evolution. Eventually, humankind emerged, standing on Earth's surface, gazing up at the stars, pondering their origins and the vastness of the cosmos. This narrative of the cosmos, its origins, and its history has been painstakingly pieced together over centuries by the collective effort of thousands of people. Modern science allows us to confidently discuss events that are both ancient and distant, stretching our imaginations. This achievement stands as one of the greatest of our species, considering it was accomplished from a vantage point on the surface of an insignificant rock hurling through space. While we have unraveled some of the universe's beginnings, the data from particle physics and astronomy indicates that we still comprehend only a fraction of the cosmos. Observing the sky reveals that matter is organized on a grand scale into galaxies and clusters of galaxies. Galaxies contain stars, planets, and gases. Everything visible in the universe, including the Earth, Sun, stars, and galaxies, is composed of protons, neutrons, and electrons bound together as atoms. Physicists have developed a profound understanding of the fundamental particles and forces that govern ordinary matter around us. Centuries of discovery have taught us why apples fall from trees, how Earth orbits the Sun, and that Earth is not the center of the universe. This picture is simple and elegant, yet the quest to answer fundamental questions about the universe has reached a pivotal moment. Astrophysical and cosmological observations have revealed that our understanding of the universe remains incomplete. One of the most astonishing discoveries of the 20th century was that ordinary matter constitutes less than 5% of the universe's total mass. The remainder is comprised of dark matter, a mysterious invisible substance, and dark energy, a force that counteracts gravity. Dark matter, an exotic substance, does not emit, absorb, or reflect light, making it invisible. Its existence is inferred from its gravitational effects on galaxies. At approximately 10 million times the distance between the Earth and the Sun, stars on the edges of spinning galaxies move at nearly the same speed as those near the galactic center, where visible matter is concentrated. This phenomenon suggests the gravitational influence of unseen mass, a halo of dark matter enveloping the galaxy. Dark matter could also explain optical illusions seen in deep space, such as strange rings and arcs of light. These distortions occur when light from distant galaxies is bent and magnified by massive invisible clouds of dark matter, in a phenomenon known as gravitational lensing. The radical conclusion that the universe is filled with nearly undetectable matter echoes past paradigm shifts, such as realizing Earth is not the center of the solar system. Like ordinary matter, dark matter traces its origins to the Big Bang. Its distribution influenced the evolution of the universe, leading to the formation of stars and galaxies in regions with higher concentrations of dark matter. Today, the cosmic web we observe reflects the distribution of dark matter in the early universe. This enigmatic substance acted as an unseen force, guiding the growth of galaxies. The exploration of this unknown universe demands a deeper understanding of the fundamental physics underlying dark matter. Recent advancements, such as those from the James Webb Space Telescope, hint at discoveries yet to come. Recent images from the telescope have revealed potential dark stars, objects possibly powered by dark matter, the invisible substance that dominates the universe. Scientists first proposed the existence of dark stars in 2007, led by Catherine Fries, a cosmologist from the University of Texas at Austin. According to Fries, dark stars would be fundamentally different from ordinary stars like our Sun. While normal stars derive their energy from nuclear fusion of hydrogen atoms, dark stars would potentially be powered by the annihilation of dark matter particles. Dark matter, whose nature remains elusive, interacts gravitationally with visible matter, such as galaxies, but it could also self-interact, producing heat and light sufficient to form and sustain these celestial bodies. These dark stars couldn't form in today's universe due to the scarcity of dark matter. However, they might have emerged in the early universe, shortly after the Big Bang when clouds of hydrogen, helium, and dark matter were abundant. As dark matter particles annihilated each other within these clouds, the resulting heat prevented complete collapse, allowing these bodies to grow exceptionally large, up to 10 times wider than Earth's orbit around the Sun and potentially billions of times more massive and brighter than our Sun or even an entire galaxy. The James Webb Space Telescope, designed to explore ancient and distant cosmic objects, may have already detected signs of these hypothetical dark stars. Fries and her colleagues analyzed data from Webb's observations of high-redshift galaxies dating back nearly 14 billion years. They identified 3 candidate objects, JADS RGS 2-1, JADS RGS 2-2, and JADS RGS 2-13, with characteristics resembling what dark stars might exhibit, high redshifts and possibly point source emissions indicative of stars rather than fuzzy galaxies. Confirming the existence of dark stars would provide compelling evidence for the presence and behavior of dark matter. It could also offer insights into the formation of supermassive black holes, which remain mysterious in origin despite their prevalence in galactic centers. These cosmic behemoths, millions or billions of times more massive than our Sun, could potentially form from the remnants of dark stars after the annihilation of dark matter within them. In essence, our journey into the cosmic dawn continues, with the James Webb Space Telescope leading the way. Each discovery brings us closer to unraveling the secrets of the early universe and understanding the forces that shaped it. The high redshift galaxies observed by Webb serve as time machines, allowing us to peer back into the past and inch closer to understanding the enigmatic origins of our cosmos. Explorers of the unknown, we stand at the brink of discovery, poised to uncover more about the universe's mysteries. In recent news, scientists using a NASA space telescope have made an exciting discovery: a tantalizing world approximately the size of Earth, situated remarkably close to our solar system and potentially suitable for life as we know it. The extrasolar planet, or exoplanet, named GJ1214b, orbits a small, cool red dwarf star located approximately 40 light-years from Earth in the constellation Pisces. Discovered by NASA's Transiting Exoplanet Survey satellite TESS, GJ1214b is estimated to be about 1.1 times the width of Earth, placing it in size similarity with both our planet and Venus, often referred to as Earth's solar system twin. GJ1214b orbits its star, GJ1214, so closely that its year lasts just 12.8 Earth days. However, because the red dwarf GJ1214 is about a quarter of the size of the Sun, it emits significantly less heat. This positions GJ1214b within the habitable zone of its planetary system, also known as the Goldilocks zone. This zone is crucial as it denotes an area around a star where conditions are neither too hot nor too cold for liquid water to exist, a vital ingredient for life as we know it. Scientists are cautiously optimistic about the potential habitability of GJ1214b due to its proximity to Earth and its position near its star's habitable zone. Lisa Senna and Shash Sharda, leading researchers in the discovery, note that while GJ1214b receives about 85% of the radiation Venus gets, its cooler surface temperature of 107 degrees Fahrenheit (42 degrees Celsius) makes it more conducive to life. Unlike Venus, which has a thick atmosphere trapping heat, GJ1214b may have a relatively thin atmosphere, which is favorable for habitability. The exoplanet orbits a calm red dwarf star, which increases its chances of retaining an atmosphere despite the frequent and powerful flares typical of red dwarfs. The discovery provides an opportunity to explore planetary conditions around red dwarfs, which constitute a significant portion of stars in the Milky Way and have much longer lifespans than the Sun, offering more time for potential life to develop. Future studies using methods like the radial velocity technique and transmission spectroscopy with the James Webb Space Telescope aim to reveal more about GJ1214b's atmosphere and potential biosignatures. This exoplanet, along with others in the TRAPPIST-1 system, represents a significant step in understanding potential habitability around red dwarfs. While it's too early to determine if GJ1214b can support life, further research is eagerly anticipated. Kelowna remains hopeful, emphasizing the importance of continued study. The episode concludes by encouraging viewers to engage with the content and support further research.